Welcome to T1 Academy. In our last session, we started discussing about the number system concept and we solved some of the problems from the number systems. So in this session, we are going to discuss about our units digit concept and the number of zeros concept, students. So when it comes to this units digit, what is this units digit? See, when you add two numbers or when you multiply two numbers, usually what happens when you add two numbers, something like this. For example, take an example, some 243 plus 478 plus 942, something is there for us. Okay, when you add these three numbers, usually what we are going to do, 243, 478 and 942. Okay, when we add these numbers, we only concentrate on the units digit, right? That means when we add 2 plus 8, what it is? 10. 10 plus 3, it becomes 13. 1 will go as a carry and what we will have in the units place 3. What we will have in the units place 3. In a similar manner, when you add 3 plus 8, what it becomes? 11. Okay, we will not bother about this one. We only concentrate on the digit which is present at units place. So 1 plus 2, what it becomes? 3. So the unit digit will become what? 3. So the unit digit becomes here what? 3. So in this manner, we are going to observe the 3 here. Understood, students? So 3. Similarly, if there is a product, that means when I want to multiply some 243 with 478, usually what is the procedure when we multiply it? We multiply 8 with 3. 8 3s are 24, we will write. Okay, and we will not add anything to this 4 once again till the end. Okay, why? Because this 4 will not be disturbed at all till the last and directly we will write it as 4. Directly we will write that one as 4. So because of that reason, if there is something like this, 243 into 478 into some 942 like this, what usually we do here is 3 8s are 24. Okay, good, superb. We will not bother about 2. We only continue with 4. 4 2s are 8 and we will write our unit digit as 8. Okay, understood, students? So the reason behind that is when we add or multiply, the units digit will not be disturbed at all, irrespective of the length of the numbers. How many numbers you multiply, we will not bother. We only concentrate on the units place. The digit which is present in the units place. Okay. Now, similarly, see here, students, when there is 1 0 in the units place, for example, something like this, 243 into 432 into 450, what will be the units digit in this case? We have 1 0 here, right? When you multiply 0 with any number, what is the unit digit which we are going to get here? 0. We are going to get 0 as the units digit, irrespective of the length of the number, whatever may be the digits we have. If we have one digit in the given series, definitely at the end we will get a 0. Understood, students? Now similarly, for example, we have one digit which is very, very special. That digit is 5. If we have 5 is in the units place, usually what happens? See here, when you multiply 5 with 2, what is the unit digit you will get? 0. 5 2s are 10. Units place is 0. Similarly, 5 4s are 20. Units place is 0. 5 6s are 30. Units place is 0. 5 8s are 40. Units place is 0. That means when the digit 5 in the given series of numbers, if we have 5 in the units place, and we have at least one even number in the given series, then obviously our answer will become what? 0. Our answer becomes 0. And similarly, when we multiply 5 with the odd digits, 5 1s are 5, 5 3s are 15, units place is 5, 5 5s are 25, units place is 5, 5 7s are 35, units place is 5, 5 9s are 45, units place is 5. That means when we multiply 5 with any even digit, we will get the units place as 0. And similarly, when we multiply 5 with any odd digit, we will get the units place as 5. So keeping these things in our mind, whenever we solve any problem, first of all, we will look for 5s. There is 1 5 in my units place or not. If there is 1 5, okay, then immediately we will check whether there is an even number in the given numbers in the units place or not. If there is one even number, if at least one even number is there, then obviously the answer will become what for us? 0. If there are no even numbers at all, that means only completely odd numbers are there, then our answer will become what? 5. We will take some examples, students. Take an example, something like this. 254 into 253 into 255 into 257. There is a question like this. I need to multiply all these numbers. See here, in this question, I have 5 at units place. Then immediately I will check whether there is an even number in any of the given numbers in units place or not. Yes, I have 4 here. So the answer for this question, without solving anything, I will write my answer as 0. Why? Because 5, when I multiply with any even digit, what is the units place? We will get 0. 0, and when you multiply with any other number, what will be the output? 0 itself. Okay, and similarly there is one more example, something like this. Take for example, I have 243 into 245 into 247 into 249. Now I need to find the units digit of this product. Now see here, in this product also I have 5. Now I will check whether there is at least one even number. One even number is enough, students. Is there any even number in this case? No, I have 3, 5, 7 and 9. All these are what? Odd digits. Then obviously my answer will become what? 5. Without solving, directly I will write my answer as 5. So why? Because when I multiply 5 with any odd number, what is the unit digit? I will get 5 always. See here, 3 5s are 15. I will not bother about 1. I will go with 5. 5 7s are 35. I will not bother about 3. I will go with 5. 5 9s are 45. What is the final answer? I will get 5. So whenever in the given question, if the question is very lengthy, students, your first thought should go on to 5. Whether there is 5 in the given numbers or not. If there is no 5, we don't have any other choice. We should follow our basic method, how we have solved the previous examples like this. For example, if the question doesn't have any 5s, okay, there is a question like this. A question which don't have any 5, we have a question like this. Some 241 into 242 into 243 into 244 into 246 into 247. There is a question like this. This is very lengthy. Now in this question I don't have 5, right? So then immediately I will go with my basic procedure only. 1 2s are 2, unit digit is also 2, 2 3s are 6, unit digit is also 6, 6 4s are 24. I will not bother about 2, I will go forward with 4, 4 6s are 24. Once again I will not bother about this 2, I will go with 4, 4 7s are 28. So my units digit for this product will become what? 8. If I have 5 in the given numbers, then I will check whether at least one even number is there or not. If there is one even number, we will write my answer as 0. If there are no even numbers, if it contains only odd numbers, odd digits, then I will write my answer as 5. Okay, units digit, this is the major observation which you need to make. And along with the students, the next important thing is about the powers. If you have powers in the units place, okay, if you have powers in the units place, how you are going to solve that one, that is very, very important. Okay, so when you have powers in the units place, now see here, the last digit of the numbers, please see here students, the last digit of the number obtained by multiplying the numbers 81 till 88, 89 will be. Now please see here, already I told you, whenever you have these type of questions, 81 into 82 into 83 into 84 into 85 into 86 into 87 into 88 into 89. Now whenever you see this type of question, our first glance should go to 5. Whether we have 5 at units place. Yes, we have 5 at one place, that is we have 5. Okay. Next, is there any even number? Yes, there are many even numbers, 2, 4, 6, 8. So 5 with one even number is enough. We can directly say our answer is 0. There is no need to calculate anything. Directly you can say that the unit digit of or the last digit of the numbers multiplying this will become what? 0. Why? Because I have a 5 and I have a even number. Many even numbers, 5 with one even number, I can directly say that unit digit will become 0. Why? Because when I multiply these two, you will get unit digit as 0. 0 into anything will become what? 0 only. So unit digit for this one will become 0. Okay, good. Next one. The units digit of the product 3127 whole to the power of 173 is. See here, what is the unit digit I have in this case? 7. The unit digit I have in this case is 7. So whenever we have 7, for 7 how many chances do we have? 4 chances. So immediately divide the power with 4. That means what? 173 by 4. 173 by 4. Now see here students, the divisibility. While learning the divisibility rule of 4, we learnt. No need to worry about the complete number, only check the last two numbers. So 73 by 4. What is the remainder for 73 by 4? No need to check the complete number. Last two digits is enough. 73 by 4. What is the remainder? 1. So remainder is 1 here. So what you will do? 7 to the power of 1. What it is? 7. 7 to the power of 1 is 7. So our answer here becomes what? 7. So the unit digit of 3127 whole to the power of 173 is 7. See students, we will not bother about these remaining numbers. We only concentrate on the digit which is present at the units place. Here we don't require the complete number. Okay, next one. See here, the units digit of the product 7 to the power of 71 into 6 to the power of 59 into 3 to the power of 65. What will happen to this? See here, 7 to the power of 71. For 7 how many chances we have? 4 chances. So 71 by 4. 71 by 4. What is the remainder? I will get 3. So I need to write the unit digit of 7 cube. 7 cube is what? 343. So this units digit will become what finally for me? 3. 343. So 3. Next, anything 6 to the power of anything, always we will get the same units digit, that is 6 only. We have seen for 0, 1, 5 and 6 we will get the same 0, 1, 5 and 6. So anything to the power of 6 we will get always 6 only. Okay, good. Next, 3 to the power of 65. For 3 how many chances we have? 4 chances. So we will divide the power with 4, that is 65 by 4. What is the remainder I am going to get here? Remainder is 1. So 3 to the power of 1 is 3. So the same 3 will come here. So that same 3 will come here. Now we need to find the unit digit of this one. 3 6 are 18. 8 3s are 24. So our final answer will become what? 4. So the unit digit of this product will become what? 4. The unit digit of this product becomes 4. So in this manner you are going to find the units digit of the given powers or products, whatever it may be. Next one. The units digit of 7 to the power of 95 minus 3 to the power of 58. This is the question which we have. For 7 how many chances we have? Just now we have seen 4 chances. So divide the power with 4. 95 by 4. Remainder is 3. Remainder is 3. So 7 cube. Okay, good. 7 cube means unit digit will become what? For this 3. So for this entire number the unit digit will become 3. Now come to 3 to the power of 58. For 3 also we have 4 chances. So 58 by 4. What is the remainder you are going to get here? 2. So 3 square is what? 9. So unit digit will become what? 9. So 3 minus 9 I have. See here students, 3 minus 9 in the sense, the value, something will be there here and it ends with 3, the first one. And something will be there and it ends with 9. Now when I subtract these two things students, what will happen in general is, actually I cannot subtract 9 from 3, right? So usually what we will do, we will take a borrow. Am I correct? We will take borrow and whatever may be the number here it is, always the final we will get 10, right? So when I take 10 borrow, this overall value will become what? 13. Overall value will become what? 13. So instead of 3, now this 3 will become what for me? 13. 13 minus 9, so unit digit will become what? 4. Unit digit becomes what here? 4. Like this we will have the subtraction students. Understood? Usually we will not get subtractions, but very rarely we will get. If we get also like this, we need to solve the question. Okay, understood? We have 3 minus 9. Actually we cannot take 9 from 3. But in that cases, usually what we will do in our subtraction method, we will take the borrow, right, from the previous one. Whatever may be the number, we can take borrow. So when I take 10 as a borrow, this 3 will become what? 13. 13 minus 9, what it becomes? 4. So our answer for this question will become what? 4. 4. Understood? Right? Next one. What is the digit in the units place of 2 to the power of 51? 2 to the power of 51. For 2, how many chances do we have? 4 chances. So divide the power with 4. So 51 by 4. What is the remainder we are going to get here? Remainder is 3. Remainder is 3. So 2 cube value will become what for us here? 8. 2 cube value will become what? 8. Anyway, units digit is also 8. So we will get the answer as 8 here. Okay. Next one. What is the rightmost digit preceding the zeros in the value of 30 to the power of 30? Okay, in our first introduction also we have seen this same problem. We will see it now. Now see here, they are asking us rightmost digit preceding to the values of zeros. That means what I can write actually this value as 3 into 10 whole to the power of 30. 3 into 10 whole to the power of 30. So this will become what for me? 3 power 30 into 10 to the power of 30. Right? 3 power 30 into 10 to the power of 30. So now anyway this will become what for me? Zeros. And they are asking us rightmost digit means the unit digit of 3 power 30, right? 3 power 30, that means indirectly they are asking us to find the unit digit of 3 power 30. 3 power 30. So for 3, how many chances we will have? 4 chances. Because of that reason I will divide the power 30 with this power 30 with 4, and the remainder which I will get here is what? Remainder which we will get is 2. So 3 square is what for me? 9. 3 square is what for me? 9. So the rightmost digit preceding the zeros will become what for us? 9. 9. In this manner you need to solve the questions from units digit concept. Understood, students? Okay, nothing to worry, very simple concept. They may give us in a combined manner or in an individual manner, whatever may be the question, but our process remains same here. Okay, next one. Right, our next concept is number of zeros. Our next concept is number of zeros. How to find the number of zeros in the given product? How to find the number of zeros in the given product? First of all, we should understand what is called this number of zeros here. What is called as number of zeros? See here, in any product, the zeros which we will get at the end, we call it as number of zeros. The zeros which we get at the end, we call it as number of zeros. For example, after multiplying two different numbers, if my output is something like this, 20300, 20300, then the number of zeros in this is 2. Why? Because the zeros which are present at the last, we will consider them as number of zeros. Okay, we will not bother about the zeros which are present in the middle. We only concentrate on the zeros which are present at the last. So these zeros we count them. How many zeros are there? 2. So the product in this answer, the number of zeros will become how much? 2. 2. So we will now only concentrate on this zeros which are present at the last, not the complete zeros. Okay, understood? Okay, right. Next one. Generally how the questions will be there. See here, students, while discussing the units digit concept, we discuss one important thing. When we will get 0 at the units place generally, when we will get units place at the 0 at the 0 at the last, when we have 5, when we multiply 5 with any even number, we will get a 0, right, at the units place. 5 4s we will get 0. 5 6 at 0. 5 8s we will have 1 0, right? That means at the units place we are getting zeros in this manner. Now please observe here, students. 4 what I can write it as 2 into 2. 6 I can write it as 2 into 3. 8 I can write this one as 2 into 2 into 2. So indirectly when we will get 1 0 means when we have a pair of 5 and 2. When we have a pair of 5 and 2, then we will get a 0. Understood? Whenever we have a pair of 5 and 2, then we will get the units place as 0. Okay, understood the students here? Please observe here, whenever we have the units place as, when we will get a 0, 1 0 means when we have 5 and 2, then we will get a 1 0. A pair of 5 and 2 will give us a 0. So, from now onwards, in all the questions, we will simply observe how many 5s and 2s are there. How many 5s and, sir, how we can observe how many 5s and 2s are there means, we know a process called prime factorization. Divide the given numbers, try to write the given numbers in prime factorization, okay, by doing prime factorization method. Then you can have number of 2s and number of 5s, and by observing those things, two things you can, for example, there are two numbers. After prime factorization, those two numbers are something like this. After doing prime factorization, I came to know that those two numbers are like this. One number is this one and the other number is some 2 to the power of 5 okay, into 3 to the power of 6 into 5 cube. Like this I got two numbers. Now I need to find the number of zeros for the product of these two numbers. For the product of these two numbers. So now when I multiply these two numbers, what I can write finally? 2 to the power of 4 plus 5 is 9. Why? Because we know one thing, a to the power of m into a to the power of n is equal to what? A to the power of m plus n. And similarly we know also know a to the power of m whole to the power of n means what? A to the power of m into n. A to the power of m into n. Now please observe here students, what I have here, 2 to the power of 4 into 2 to the power of 5. So 4 plus 5 it is 9. Next 3 to the power of 8 into 5 to the power of 4. 5 to the power of 4. Now we will not bother about the remaining numbers. We will not bother about the remaining numbers. We will only look for 2 and 5. Okay. Now what I have here, 2 to the power of 9 into 5 to the power of 4. 2 to the power of 9 into 5 to the power of 4. Now tell me how many pairs of 2 and 5 I can make with this one? How many pairs of 2 and 5? I can make 4 pairs. Why? Because the least power is 5. The least power among 9 and 4 is what? 4. Because of that reason we can make only 4 pairs of 2 and 5. For example students, you have 9 right leg shoes and 4 left leg shoes. 9 right leg shoes and 4 right leg shoes. Now tell me how many pairs of shoes you can make? You can make only 4 pairs of shoes. That remaining 5 left leg shoes are waste. We cannot make any pair with them. So similarly here also, with 9 2s and 4 5s, I can make only 4 pairs. So then the product, this product will have how many zeros at the end? This product will have 4 zeros at the end. This product will have 4 zeros at the end. Simply, irrespective of the number, whatever may be the number, we will simply do the prime factorization and write them in this manner. And then after writing them, we will observe how many 2s and 5s are there. Whichever the power which is less, that means sometimes see is here. Example, after multiplying two numbers, you got something like this. 2 to the power of 4 into 3 to the power of 9 into some 5 to the power of 7. Now anyway we will not bother about these 3 powers, we will only look for 2 and 7. What is the least power among 4 and 7? 4. So that means we can make 4 pairs, so the number of zeros also will become 4. Understood students? Okay, whatever the power which is less in value, then that will become our number of zeros answer. That will become our number of zeros answer. Understood? Right? Like this we are going to solve the problems. Like this we are going to solve the problems by simply observing how many 5s and how many 2s are there in the given product. Okay. Next. Now see here, find the number of zeros in the product 56 power 99 into 125 power 89. Okay. I need to find the number of zeros in 56 power 99 into 125 power 89. So before that, first of all I need to do the prime factorization for 56. When I do the prime factorization for 56, what it becomes? 2 28s, 2 14s, 2 7s. So what I can write 56 as 2 cube into 7 to the power of 99 into 125, directly I can write that as 5 cube. 5 cube whole to the power of 89. If you do prime factorization also, you will get the same answer students. Okay, no need to worry. Okay, now please observe here, a to the power of m whole to the power of n means a to the power of m into n. 99 3s are 297. 99 3s are 297 into 7 to the power of 99 into 5 to the power of 89 3s are 267. 89 3s are 267. Now we will not bother about the remaining prime numbers. We only concentrate on 2s and 5s. How many 2s I have? 297. How many 5s I have? 267. Now tell me how many zeros I can have here? I can have 267 zeros here. Okay, we can have here 267 zeros. So the number of zeros for this question will become 267. Simply do the prime factorization. After doing prime factorization, observe the powers of 2 and 5. That is enough. Okay. Next one. How many zeros are there at the end of the result of the expression 5 to the power of 10? Okay. Now my question is 5 to the power of 10 into 10 to the power of 10 into 15 to the power of 10 into 20 to the power of 10 into 25 to the power of 10. We need to tell how many zeros will be there at the end of this expression. At the end of this expression. Now please see here students, 5 to the power of 10, I can write it as 5 to the power of 10. 10 means what? 2 into 5, right? So 2 into 5 whole to the power of 10 into, see students, as I am writing or as I am explaining here, I am writing each and every step, but in general there is no need to write all these things. Directly you can write them in a splitted manner. So 3 into 5 whole to the power of 10. 20 means what actually? 2 into 5. That means 2 square into 5 whole to the power of 10. And 25 means what? 5 square whole to the power of 10. See here students, with some common sense we can solve this question. Anyway, 5s there are many in number, right? I have here 10 5s, here 10 5s, here 10 5s, here 10 5s, here 20 5s. I have 5s in many numbers. So no need to waste your time by counting 5s one. Only count 2s. How many 2s you are getting? Count here. Here what I will get here? 2 to the power of 10. I am only counting now 2s here students. Here what I will get here? 2 to the power of 20. Overall, how much power of 2 I will get here? 30. See, anyway I will get more than 30 for 5. See here, here I have 25s, here I have 10. From these two only I got 35s, right? So no need to count the remaining 5s. It is waste of time. Directly you can say that the number of zeros here will become how much? 30. The number of zeros here will become 30. If you want you can count also. Here 10, 10, 20, 30, 40 and I have here 20. So 5 to the power of 60 actually I have. I have 5 to the power of 60, but 30 and 60 which one is less? 30. So we will have 30 number of zeros at the end of this product. 30 number of zeros at the end of this product. Understood? Right. Next one. What is the largest value of n such that, see, this is one of the previous year's question students. What is the largest value of n such that 10 to the power of n, 10 to the power of n divides the product. This is the product which we have. This 10 to the power of n should divide this one. See here students, very simple. If a number want to be exactly divisible by 10 means, what should be 10? It should end with 10, right? Then it will be exactly divisible. Okay, if a number want to be divisible with 100, it should, last 2 digits should be zeros, right? Minimum. Then it will become zeros. If a number want to be divisible with 1000 means, the last 3 digits should be what? Definitely zeros, then it will become exactly divisible. Now please see here, he is telling that what is should be the largest value of n. That means n should have the largest value. So 10 power n means what? We will get, how we will get 1 and we will get n number of zeros beside that. Am I correct? So to cancel this n number of zeros, in the numerator also I should get the same number of zeros, right? That means this question is indirectly the number of zeros question. Indirectly the number of zeros. Nowhere in the question he spoke about number of zeros. But this question is indirectly a number of zeros concept question. Okay. To have n value maximum. So what is the maximum value of n we can take means whatever the value of number of zeros we will have at the numerator. If you take the same number of zeros at the denominator, they will be exactly cancelable. So here we need to find, find number of zeros. This question is nothing but to find the number of zeros. We need to find the number of zeros in this. Now what will happen? Please observe here students. We will not bother about all the numbers. We will only bother about the numbers which have 2s and 5s. See here 2 to the power of 5. I will write that one. I will not take this 3 to the power of 3. It is waste of time. Next 4 to the power of 8 means 2 square whole to the power of 8. I will consider this one. Next 5 cube means we will take 5 cube. Next 6 means what students? 2 into 3. 2 into 3. I will not bother about that 3. I will only take 2 to the power of 7. Please see here 6 to the power of 7. I am writing it as 2 to the power of 7. Why? Because 6 I will write it as 2 into 3. I am not worrying about this 3. Okay, I am only concentrating on this 2. I will not bother about 7. Next 8 means what? 2 cube whole to the power of 12. 9 to the power of 9 means 3 square root to the power of 9. I don't require this one. Next 10 means what students? 2 into 5 whole to the power of 6. 2 into 5 whole to the power of 6. 10 to the power of 6 means 2 into 5 whole to the power of 6. Next 15 to the power of 12 means 15 means what? 3 into 5. I will not bother about 3. I will only take the 5. 5 to the power of 12. Next 20 means what students? 2 square into 5. 20 means 2 square into 5 whole to the power of 14. into 22 means what? 2 into 11. I don't require 11. I only concentrate on 2. So 2 to the power of 11. Into 25 means what? 5 square whole to the power of 15. 5 square whole to the power of 15. Right? Now please observe here. Write it quickly. 2 to the power of 5 into 2 to the power of 16 into 5 cube into 2 to the power of 7 into 2 to the power of 36 into 2 to the power of 6 into 5 to the power of 6 into 5 to the power of 12 into 2 to the power of 28 into 5 to the power of 14 into 2 to the power of 11 into 5 to the power of 30. Here don't count 2's. Anyway, we have 2's many in number. Simply concentrate on 5's. Okay. So 3 plus 6, 9. 9 plus 12, 21. 21 plus 14, 35. 35 plus 30, 64. So total we have how many 5's here? 64 5's. Now for time being, anyway that is also a huge number, we will count for 2's. So 5 plus 16, 21, plus 7, 28, 28 plus 36, it is becoming 64 and here it is 70. So it is no waste of counting 2's. Anyway, we have the minimum number, the minimum power is for 5. So 5 to the power of 64. So the number of zeros, the largest value, that means in this product at last we will get 64 zeros. To cancel this by what we can do is 1 and after 1 we can have 64 zeros, right? These 64 zeros, that 64 zeros will get cancelled and exactly divisible. So that is the reason the largest value of n I can take here is 64. The largest value of n we can take here is 64. So that we will get in the denominator as 10 to the power of 64. Indirectly it is 1. After 1 we will have 64 zeros. In the numerator also we have 64 zeros. These 64 zeros, that 64 zeros will get cancelled and we will get the final answer. Okay, understood? This is one of the important model, students. Next one. If 10 to the power of n divides, please pause the video and try to solve this one. Divide 6 to the power of 23 into 7 to the power of 9 into 10, 102 to the power 105. Okay, 6 to the power of 23, 75 to the power of 9 and 105 to the power of 2. Largest value of n. Similarly, number of zeros only. So what I can write this one as 2 to the power of 23. I am not considering 3. It is waste of time. 75 means what actually, students? 5 square into 3. I am only writing 5 square whole to the power of 9. I don't bother about that 3. Next 105 means what? 21 into 5, that is 7 into 3 into 5. I will only consider this 5 and 5 square. So now what happens to this? 2 to the power of 23 into 5 to the power of 18 into 5 square. So at last what you will get? 2 to the power of 23 into 5 to the power of 20. So what is the minimum power we have here? 20. So our answer also becomes here 20. So our answer also becomes here 20. Okay, understood? In this way we will find the n value. So the highest value of n we can take here is 20. So that this 20 zeros and the numerator 20 zeros will get cancelled and we will get the remainder as 0. Remainder as 0. Okay. Exactly divisible means what? Remainder should be 0. Okay. Next. See here, students. Okay, sir. Like this we will solve the problems by observing 2's and 5's. But in the case of factorials, there will be some questions based on factorials. What are called as factorials, ma? See here, if I have 5 factorial, what is the meaning of 5 factorial? 5 into 4 into 3 into 2 into 1. Okay. Similarly, if I have n factorial, what I can write? N factorial means what? N into n minus 1 into n minus 2 into and so on up to we reach 1. In this manner, we will write the values for factorials. Okay, good. See here, students. In the case of factorials, anyway we will have many number of 2's, right? Will you accept this one? For example, in 10 factorial means generally what you will do? 1 into 2, I am writing in reverse order, no need to worry. 4 into 5 into 6 into 7 into 8 into 9 into 10, right? If you compare the number of 2's and 5's, usually in any product what we used to do previously, we used to observe number of 2's and number of 5's. Am I correct? And we will observe the power, whichever the power is lesser value, we will take that as our final answer. But in case of factorials, we will have many number of 2's, right, in general. Why? Because see, in 2 we will have 1 2, in 4 we will have 2 2's, in 6 we will have 1 2, in 8 we will have 3 2's, in 10 we will have 1, 2. But when it comes to 5, we will have 1, 5 here, we will have 1, 5 here. So, in case of factorials, we will only observe how many 5s are there. Based on that, we will write our answer directly. We will not bother about 2s. Why? Because anyway 2s will be many in number. It is waste of counting 2s. So, in case of factorials, okay, in case of factorials, we only calculate for number of 5s, that in term becomes, that will become number of zeros. We will count the number of 5s and that number of 5s will become our number of zeros directly. Why? Because anyway 2s will be many in number. It is waste of counting 2s. So, we will only count 5s and we will write our final answer there. We will write our final answer there. Understood? Now, please observe here, students. In this case, in the case of factorials, just now I told you. So, for example, if I want the number of zeros in 50 factorial, number of zeros in 50 factorial. Okay, sir, good. What you will do is, we will write where we will get 5. See here, in 50 factorial at 5 we will get, see, I am only writing the numbers where we will get 5s. Okay, I am not writing all the numbers, I am writing only the numbers where we will get 5s. Those are nothing but the multiples of 5. 5 into 10 into 15 into 20 into 25 into 30 into 35 into 40 into 45 into 50. Okay, now please observe here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will have 10 multiples. Okay, sir, good. That means 10 zeros? No. Why? Because at 25 we will have one more 0. Why? Because 25 I can write as 5 square. At 50 also we will have 1 0 in excess. 5 square into 2. 50 I can write as 5 square. Whereas all the remaining numbers I will have only 1 5s. So, total what will be my answer? 12. Sir, this is 50 factorial. So, you have written and you have counted. But if my question is some 168 factorial, then what I can do? See here, students, in case of factorials, what we are going to do is, we will divide the given number with 5 powers. 5 powers. That means, for example, if I want 50 factorial, number of zeros in 50 factorial, what I will do is 50 by 5 to the power of 1. What it is, and I will observe the quotient, whether it is exactly divisible or not, we will not bother. Quotient is what for me? 10. 50 by 10. In this case, it is divisible, so 10. Next, 50 by next power of 5 is what? 5 square, that is 25. 50 by 25, what is the quotient? I will get 2. Next, 50 by 5 cube. What is 5 cube actually? 125. 50 by 125. What is the quotient? We will get 0. Why? Because 50 is lesser than 125. So, we will stop. From now onwards, anyway, all the values will get 0 only. So, quotients you will get 0. So, the number of zeros will become how much? 12. 12. For example, if I want to find the number of zeros for 168 factorial. 168 factorial. So, what I will do? 168 by 5 to the power of 1. So, what is the quotient? Whether it is exactly divisible or not, we will not bother about it. So, what will be the quotient? 168 by 5? 33. 165 is exactly divisible by 5. So, 33s are 165. Next, 168 divisible by 5 square. 5 square is what? 25. So, 168 by 25, what is the quotient I will get? 25, 6 are 150, right? So, quotient will become 6. Next, 168 divisible by 125. Why? Because 5 cube is 125. So, what is the quotient I will get here? 1. Next, 168 divisible by next power. 5 to the power of 4 is 125. 5s are 625. From now here onwards, what is the quotient? We will get zeros only. Why? Because denominator will become greater than numerator. So, what will be my answer here? 33 plus 6 will become 39. 39 plus 1, it will become 40. So, the number of zeros for 168 factorial will become what for us here? 40 zeros. We will get 40 zeros. So, in this manner, we are going to write the number of zeros for factorials. If it is a normal question, we will observe how many 2's and how many 5's are there. But in the case of factorials, anyway, we will have many number of 2's, we will only observe the 5's. So, how we will observe the 5's means by dividing it with 5 powers and observing the quotients. That is enough. That is enough. Understood, students? In this manner, we will now take an example. Tell me how many zeros you will have in 224 factorial. Please find the number of zeros in 224 factorial. Students, what you should get is 44 plus 8 plus 1. You should get 53 as the answer. And similarly, if you want, why? Because 224 by 5 is 44, 224 by 25 is 8, 224 by 125 is 1, and after that anyway all will become zeros. So, the answer for that will become what? 53 zeros. So, in this manner we are going to get the number of zeros. So, students, this is the complete concept of our number of zeros and unit steady concept. So, later we will solve the problems at a time from our factors cases, from the different types of questions and all those things. But first of all, this is the concept of unit digit and number of zeros. In our next sessions, we will see how to find the reminders in general method and in using the Euler's remainder. Okay, thank you very much. We will see in the next session.